Hi, boys and girls. You know, today we're going to be talking about force and motion. On my board, I wrote that force equals motion. If I have a car like this and I want it to move, I have to use force to put the car into motion. This car won't just move. There has to be some sort of force acting upon it. I can push the car or I can pull the car. A lot of times when you are in a store or a public place, you'll see doors that will say push or pull. That's how you move the doors. You use force. The force that you use is either a push or a pull. If you push something away. If you pull, you bring it closer. We're going to read part of a book called Forces Make Things Move. Now, this is a very long book and it has a lot of good information in it. So we'll read part of it now and part tomorrow and maybe part on Friday. I haven't decided if we're going to do 2 days or 3, but I think we'll just start today with part. Forces make things move. Now, yesterday was the 4th of May, so people say, may the 4th be with you. So if you are a Star Wars buff, meaning you really like the Star Wars movie, they talk about the Force, right? If you think about when Luke and Yoda are using the Force, they're making things happen with their minds, and that's what their force is. Our force is usually our bodies. If you push a toy car, you can make it move across the floor. Your push moves the car. Your push is a force. Forces get things moving. Forces also make things stop. When the toy rolls across the floor and stops, a force stopped it. Forces also make things speed up or slow down. Any push or pull is a force. Forces can move things farther away or bring them closer. Some forces are very strong. Some are so weak you can't feel them at all. Nothing starts moving until it is pushed or pulled. If you don't push your toy car, it just sits there unless something else pushes it, like the wind or your cat or your big brother. The wind, your cat, and your big brother can all produce force. The force moves your car. Anytime your car is moving, a force made it start. The heavier an object is, the more force it takes to start moving. If you want to run across the yard, your feet have to push on the ground to get you moving. If you and your big brother decide to have a race, his feet will have to push harder on the ground than yours. Why? Because he weighs more. It takes more force to make him move. Once you are running, only another force can stop you. Your feet push on the ground to make you stop. If you want to stop quickly, it takes more force than if you want to stop slowly. Think about a car. If you're driving a car, you have a pedal that's called a brake pedal. When you push on that pedal, it slows and stops your car, right? If you are ever with your parents and something happens and your parents have to stop quickly, they slam on that brake, right, to try to stop quickly. If you're just rolling up to a stop sign, they probably push in on that brake slower. That brake is the force that is stopping the car. Once you are running I already read the part. It takes a lot of force to start heavy things moving. That's why your living room couch doesn't fly across the room when you bump into it. It's why a breeze can't blow your family's car off the driveway. Other things like leaves and papers and hats don't weigh very much. Even tiny forces can make them fly around. A little wind makes enough force to make them move. But if your big brother is lying on the living room couch, you're going to have to push pretty hard to force him off. Whenever you push something, it pushes back against you. If you push a toy car, it pushes back against you with the exact same force. If you push harder, the toy car pushes back harder. This can be difficult to understand, but it's true. The force you put on the car is always the same as the force the car puts on you. If you push the toy car, your force makes the car start moving. So if the toy car is also pushing you, why don't you start moving? Because you are so much heavier than a toy car. Remember, it takes more force to move heavy things. The force that can move a toy car can't move you. Since it takes such a small amount of force to move the toy car, and the toy car puts only that much force on you, the force is too small for you to feel. If you push your family's real car parked in your driveway, it pushes back too. Just like your toy car, the real car pushes back with the same amount of force as you put on it. If you push the real car gently, it pushes back gently. If you push harder, you can feel it push back harder. You can't produce enough force to move the real car, neither can your big brother. Sometimes you can, well, we're going to stop there because I think that's a good stopping spot, because tomorrow we'll talk about more. Now, this morning in your science lesson, we talked about force and motion and push and pull, and I showed you some different experiments that you can do. Now, I know that you already have probably tried these, but maybe now that you've heard a little bit more, you can think about what was happening and maybe try it again. You know, when you push the car, it's going to take more force for a smaller car or for a larger car than for a smaller car, right? But think about if you had a ramp and you were trying to move up. Does it take more force or less force to move it up? You ever thought about that? So think about this morning's science lesson and how what we just talked about related. We learned that when we push on something, it pushes back on us with the same amount of force. So if you're trying to move a piece of paper, it's going to take less force to move it than a book, right? And that piece of paper that's pushing back on us is not going to move us because we're heavier. It takes more force to move your body than the thing that you're pushing back on is lighter than you. But what if you're pushing on something heavier? You're probably not going to be very successful, right? Because it's going to be pushing it back on you. Anyway, that is a lot of information, and it's a little complicated to think about, but we'll be talking more about force and motion this week and the different things that affect it. So hopefully you'll do some experimenting at home and learn a little bit more about pushes and pulls as forces and how different pushes and different pulls affect the things that you are working with.